Hi, I'm with Dave Schultz, author of an upcoming paper in BAMS on Occluded Fronts. And Dave, how did you get into this line of research?
Well, I've been working on this topic since my master's thesis in the late 80s and early 90s. And what we discovered when we did that work was that there were a lot of problems with the Norwegian cyclone model. And I'm one of the biggest fans of the Norwegian cyclone model, but at the same time I recognized that it needed to be fixed in a lot of ways. And so the research at that time was asking the questions, what do we know about the Norwegian cyclone model, what is accurate, and what is inaccurate and needs to be fixed. And so we made some suggestions at that time in a paper, and I continued to work on that paper, work on the topic for my PhD thesis, and had some good results, and they answered a lot of the questions that I had. But ultimately I was still always a little bit unsatisfied with where we sat. I didn't feel like we had the complete answer. And so I gave a presentation several years ago at the Cyclone Workshop where I had some ideas that I wanted to present and say, well, you don't really need baroclinic effects. You don't need strong temperature gradients and the dynamics that go along with those in order to produce the occluded front, the narrowing of the warm sector, the catch-up of the cold front and warm front. These were some ideas that I had. I wanted to present to the Cyclone Workshop community. And that went well. And so as I was working on the paper last summer, sitting down writing it up, I realized I have more here than just that one little aspect. There were pieces of the Norwegian cyclone model, of the conventional wisdom that we've all been taught that appears in textbooks, from popular books for the public to the introductory books that we use for our first year students, non-majors in meteorology, all the way up to our books that we use for the graduate students are incomplete, presenting material that isn't supported by observations. And the more I thought about this in the context of what I was presenting, I realized I had more a complete theory about these things that really took some of these misconceptions about occluded fronts and cyclones, put it into a new context, and I think really addresses and gives us a better understanding of what occluded fronts are. And in that way, it's not a total replacement for the Norwegian cyclone model and our conventional thinking, but I think for the first time, at least in my understanding, I've been able to take out a piece of our conventional wisdom and replace it with something that's not just taking it out and going, yeah, this is wrong, and leaving a big gaping hole where people go, well, I still don't know what to say about why cyclones deepen or why the occluded front is not two fronts coming together. This new part that I've put in is a replacement and has new ideas that I think provide a seamless understanding of this process.
I'm relieved to hear that we don't have to throw everything out that we knew, but it sounds like some rethinking happened here that took a lot of time and a lot of thought. Is it going to be easy for people to sort of see what you're doing and say, yeah, oh, that makes sense, I can remember this and integrate that with my thinking?
Yeah, I think that's a really good point. It wasn't an easy paper for me to write, and it was because I almost knew too much. I knew this material so well, and admittedly some of my ideas were new and original, and so I had some difficulty of presenting it. But I think the bigger problem is, how do I write this paper, not just for a BAMS audience, where I want to speak to meteorologists in general, but I really wanted to convey the feeling when you read this paper that you don't have to be a meteorologist to appreciate it. And people who write introductory textbooks, who may be teaching, in a geography department or a geosciences department, who know a little bit about the atmosphere but don't know, all the classic papers in synoptic meteorology. I was hoping that these people could pick up this paper, and yes, I have all the citations in there. I explain these concepts, but I try to use analogies where I can. I try to keep the jargon out of it and just say, hey, look, this is what is in a lot of these textbooks. This is what we've been teaching, and let me show you why it's wrong. Let me give you something new and show you why this is better. And I hope that the reader of this article really finds that to be the case, because it was not easy for me to write, because I had to take off my scientist hat and say, I'm not writing for my colleagues in synoptic and mesoscale meteorology anymore.
Mm-hmm. Now, this is also a kind of paper you mentioned. You know that you have the citations there. Literature. That's a lot of citations, and there's a lot of literature.
I think the editor calculated 173 citations or whatever.
Yeah, we did a few backflips when we saw that. But I think that's part of the point too, is that the kind of research you do is, in a way, review. In this case, definitely review, assimilate what other people have looked at, and put it together in a conceptual way. What's difficult about that kind of writing? Because that's not something a lot of people do. They don't take time to do that.
Well, one thing I want to get straight is it's not a review article. I mean, we draw a lot of inspiration from the literature, and obviously there's a lot of good things and bad things in the literature that we use. I really like the word synthesis instead, because I'm taking what I've seen in the literature, I'm taking what empirical evidence I can get from my own research and use that to develop something entirely new. So it's why it's not a literature review where I'm looking back and saying, okay, this is what was said, and I'm now just summarizing it all in one place for you. But it's really a synthesis of, yes, there's a lot that we did do, and there's a lot of recent work by a lot of people on occluded fronts. And I want to take that information, that new recent research, the old historical stuff, and blend it together with some new ideas that we've put together into something that, there's not a lot of, there wasn't a lot of role models for me to work from. And I have to say that if it wasn't for my book, Eloquent Science, and the struggles that I went through in trying to communicate that, I don't think it would be possible to have written this paper.
Now, if you hadn't written this paper, when would somebody finally come along and done it?
Well, that's a good question, and I think the ideas were laying on the ground, and I mean, I've been thinking about occluded fronts for over 20 years, and only after this time, did some of these ideas come to me. Other people that have worked on occluded fronts, for a long time too, had made advances and made contributions. But, I don't want to think that I was divinely inspired or anything. Anyone else could have made this synthesis, but I just feel blessed that, the muses struck at the right time and shed some light on these problems, and I was prepared and to receive them and hopefully to communicate those to the readers.
I just sometimes wonder, if somebody doesn't take the time to do a synthesis, and I agree that's a much better word for this, but then it might take a long time before these kinds of reconceptualizations occur.
Yeah.
Now, now that you've done this and you've shown it around to people, has anyone said, yeah, but it still doesn't fit this situation or that situation? Do you ever get those kinds of objections? Very specific situations where you scratch your head and say, well, I think it applies, but...
I think there's a lot of complexity in the real atmosphere, and just like any conceptual model, I can't cover all the complexity, and there will be situations where you'll see structures that don't fit either the old Norwegian cyclone model or the new kind of presentations that I'm trying to give. I don't claim it to be the whole answer that will replace the entire Norwegian cyclone model. I don't even claim that it will replace our entire thinking, and I've got all the answers to occluded fronts. But I can tell you, I think this is one of the biggest intellectual leaps that I've ever had to make in my career, and the casting off of some of these old concepts, which have been ingrained in our teaching, and my education and my reading of the literature, for 20 or 30 years, isn't easy.
Yeah.
It's not easy, and I think the only thing that helps, one of the things that help, is all the reading that I have done. In some ways it could pollute you and really brainwash you and not allow you to make these conceptual leaps. But every once in a while you'll find nuggets in the literature that you can grab onto and say, now why is this person saying this? He may not have real empirical evidence to support this or whatever, but sometimes it's just enough to kick you into a little different way of thinking about this.
It also sounds like you need the skill of a critical reader when you're reading through the literature.
Right.
And I would imagine you've done a lot of tracing back the references to say, okay, where did he get that? Where did he get that? All the way back to wherever these ideas originate.
Yeah, and sometimes you don't even find the origin of them because they were on the forecast floor of people working in the Bergen School, and they certainly didn't publish a lot of detailed case studies, in their conceptual model. They just kind of unveiled it and said, well, this is how it works, and it's a very successful model, no doubt about it. It really helped gel people's thinking at the time. But
what would they say now if they saw what you're doing? Would they be shocked that we're still talking about their model all this many years
I think
later?
they would be. I mean, I think there was a lot. If you do read their case studies, if you do read some of the stuff that isn't as well cited, you'll see that they understood some of these processes. They understood that a cyclone had to have a certain depth in which to form an occluded front, and it wasn't necessarily the other way around. It wasn't the coming together of the fronts that then stopped the deepening of the front. Of the cyclone, but it was that if a cyclone doesn't reach a certain intensity, then the wrap up of the cold and warm fronts wasn't going to happen, and so it was not going to occlude. And so I think they understood this, and they talked about it, but obviously they didn't publish some of these results. But if you look at the synoptic maps, there's a lot of structure, a lot of mesoscale structure that they were witnessing, that they analyzed. They may not have understood it, and it may not have made it into all their conceptual models. But as you know, over history, there's always people taking the bare essence of the conceptual model and then representing it, and representing it, and representing it. And so, over 90 years now, I think we've distilled a lot out of the Norwegian cyclone model that they understood to be a lot more complex than the simple models that we are now presenting. And I think they probably would be embarrassed that it's hung along for as long as it has.
Yeah, that's really interesting. I'm looking forward to reading the paper again.
Thank you.